Alright guys, so it's just a little extra credit lesson. I'll throw these in once in a while. I figured this was a good time since this week is a little bit of a more chill week. There's a lot of things going on that kind of slowed down our classwork, so I thought, hey, good opportunity for some extra work if somebody has the time and wants to get a few extra points. Alright, so what we're learning is we're doing, and like I said, this is extra credit. You don't have to do this. This is just for extra points. But anyway, what this is a system of equations, but it has 3 equations and 3 variables. And so it's the thing with these is they take a lot of work, but a lot of the process is pretty much the same as what we learned last time we learned how to solve a system of equations. So I'm going to write some steps on the right over here for you that will kind of guide you through the process. So how to solve a 3-variable system. The first thing you want to do is pick 2 equations. We have 3 of them up there, but we only need to start with 2, okay? So let's do that. I'm going to go ahead and pick the first 2 equations. So let's do that. I'm going to say these 2 are my first choice. The next thing you're going to do is you're going to pick a variable to cancel. Pick a variable to cancel. So I'm just going to go ahead and pick A. You could pick anything you want to. If you're smart about it, you can actually think about which one will be easier, but that comes kind of with some experience and practice. For now, I'm just going to keep it random and say pick A. But whatever you want to do. Oh, this is a plus. Okay, so there's my 2. I'm going to go ahead and pick the A. I want to cancel out the A as my goal. And so from here, the steps are a lot like what we did with the elimination method back in substitution. And actually, it is the elimination method. So what we're going to do is we're going to flip and distribute the coefficients. Okay? So what do I mean by that? Once again, I'm going to take the coefficients off of the A and reverse them. So on the bottom, we had a negative 4A, so I'm going to put that on the top. And on the top, the A has a 2. So I'm going to put that on the bottom. And what I'm going to do is I'm going to distribute those numbers all the way across to every term. Okay, now after I do that, let's go ahead and see what we get. Okay, now what that accomplished for us is it got the A's to have the same number. So we're almost where we want to be. The next thing we're going to do is we're going to change the signs in one of the equations. One of these equations that we just made down here. So I'm going to go through and change all the signs in one of these equations. So I'm going to make this a positive 8 now. I'm going to make this a negative 2, a negative 8, and a positive 18. After that, we move on to the next step, which is to add the equations together or combine the equations. At this point, you should end up eliminating the variable that you wanted to get rid of. So in this case, notice that since the A's have the same number but they're opposite signs, when I combine these together, they cancel each other out. But we have to go ahead and combine everything together. So 20b minus 2b is going to be 18b. Negative 16 plus a negative 8 is going to be negative 24c. And then we have negative 18. Now, if you're like I said, if you kind of start getting really good at these and you know which variables to cancel, you might end up with better looking equations than mine. The reason why mine doesn't look so good right now is because the numbers are so big. I know it doesn't seem big, but it actually will be later. So if possible, reduce your equation. Okay, so if possible, reduce it. What do I mean by that? Well, look at all three of your terms. Is there anything that you could divide out of all three of those? What's the biggest thing you could divide out of all three of those? The biggest thing you can divide out of all three of those would be 6, right? So I'm going to write my answer in red here. I'm going to put reduce by 6. So if I divide all three of those numbers by 6, I'm going to end up with 3b minus 4c equals -3. So if you're smart in the beginning about which variable you cancel out, you might not have to do that step. But for me, since I'm just kind of randomly picking variables to cancel, sometimes you end up with really big numbers, and so this little step is helpful to kind of take things back down to a manageable size. You don't have to do this step, but if you don't, trust me, along the way you're going to end up with some pretty big numbers. So I advise reducing it if you can. Now, just a fair warning, guys, these problems take a lot of work, okay? We're not there yet. Here's my goal, though. I want to solve this 3-variable system, right? Well, the first thing we have to do is we want to turn it from being a 3-variable system into a 2-variable system. And I'm halfway there. I've got 2 variables here, right? I've got b and c. That's good. But in order to have a 2-variable system, I not only need 2 variables, but I need 2 equations. So I need to create another equation that has b and c in it only, without an a. How are we going to do that? We're going to repeat steps 1 through 6. Okay, we're going to pick 2 new equations. You don't want to pick the same equations you picked last time. So pick 2 different ones. And you're going to pick a variable to cancel. But this time, you need to pick the same variable. Okay, you want to cancel out the same one you canceled the first time. So I canceled out the a's. I want to make sure that we cancel out the a's again. So when you repeat steps 1 through 6, you want to pick 2 different equations. But cancel the same variable. I'm running out of space here. But cancel the same variable. So pick 2 different equations to work with, but you're still going to cancel out the a. So last time I picked the first 2 equations. This time I'll pick these 2. Okay? Now, I want to show you guys what do I mean by being smart about which variables to cancel out. If you just follow the steps, it will work. Okay, I promise you. But let's go ahead and just take a look here. So I picked 2 equations. I picked the bottom 2 this time. And we want to cancel the same variable. Now, after that, we usually flip and distribute the coefficients, we change the signs, and we combine them together. But why do we do this flip and distribute and change the signs? Well, it's so that the a's come out to have the same number but opposite signs. But look, they're already the same number with opposite signs. So I don't need to do this step or this step. I can just combine these 2 equations together and be done. So that's what I mean by being smart about it. Steps 3 and 4, you could be smart on those steps and kind of make your life a little bit easier sometimes by looking for what you could do. So in this case, if we just combine down, the a's are going to cancel right away. And 1b minus 4b is -3b. 4c minus 1c is 3c, and then negative 99 is 0. Now, just so you guys know, even though I kind of approached this a little bit differently, if you guys had done steps 3, 4, and 5, it still would have worked. You still could have multiplied the top by 4, the bottom by negative 4, and then changed the signs, and you would still get an answer. But I'm just trying to use this second run through the steps here to show you that you can be a little bit tricky about how you do these things to save yourself time. Here's another example. Remember last time how I picked the top two equations, right? And I wanted to cancel out the a's. Well, actually, it might have been a better idea to try to cancel the c's, because they're already the same number. So all you would have to do is change the signs in one of the equations and then combine them together. So there's things you can do. The goal is get those numbers to be the same but opposite signs. But if that's overwhelming to you, don't worry about it. Just follow the steps. You'll get there. Flip and distribute, change the signs, combine. You'll be good. But anyway, I have now gotten to the other half of my steps. So I have now created another equation with a b and a c in it. So I have two equations with a b and a c in it. I've got this one down here, 3b minus 4c equals negative 3. And then I have this one here, which is negative 3b plus 3c equals 0. Okay? Now, I have to erase my steps on the right, so if you need them, you might want to take a picture or something, but I need space. So what I've just done is I've started off with a system of equations that had 3 variables in it. But after doing steps 1 through 6 twice, I ended up with a system of equations with 2 variables. So now that I have these 2 equations with b and c in it, all we have to do is we have to solve the 2 variable system I just created. And that is old news. We've done that before. So if you're a little bit confused on what I mean by that, let me demonstrate.
Mr. Bailey?
All right. Sorry about that. I got a little interruption. But anyway, we have our 2 systems here. All right. So we're going to take this system here, these 2 equations. Now we're going to put these together to solve the rest of it. Uh-oh. That didn't work out the way I wanted it to at all. Let me fix all that. It's not going to work. I guess I'll just rewrite it. Okay, so we have 3b minus 4c equals negative 3. Okay, now once again, if you guys wanted to, you could totally just solve this system using the steps I've given you before, where you pick a variable, flip and distribute the coefficients, and cancel. But take a look at it. Do you see two letters that are just going to cancel already? The negative 3b and the 3b are already opposites, right? So if I don't have to go through those steps of getting them to be opposite because they're already opposite. So I can just go ahead and cancel now. 3 minus 4 is negative 1c. 0 and negative 3 is negative 3. And so if I just divide by negative 1, I get negative 1. There, and we end up with positive 3 for c. Now you're just going to take your answer and plug it into one of these equations up here. I'll use the top one. So I'm going to replace the c with 3. And then we can solve for b. And this is all just old news. So this is all step 8, just solving a 2-variable system of equations. We did that back in Unit 1. So we have c equals 3 and b equals 3. Now after you solve that 2-variable system, plug both of those answers in. To one of the original equations. To solve for the last variable. Okay? So pick one of your original equations. I'll go with the top. And we have 2a minus 5b plus 4c. And I'm going to plug in 3 for b and 3 for c. And then you just go ahead and solve. So combining negative 15 and 12, you're going to get negative 3. Add 3 on both sides. You're going to end up with, let me make some more space for myself here. Adding 3 on both sides, we end up with 12 on the right. And then dividing both sides by 2, we get 6. So we have our answer there. We have that A is 6, we have B was 3, and we have C was 3. Now technically it is possible to get fractions. However, I will say that on the worksheet I'm giving you that you shouldn't be getting any fractions. And there's so many places you can make a mistake. So it's very likely, you guys, that you're going to end up probably not getting some of these on your first try. Even I myself, sometimes doing these, I make mistakes along the way, and all it takes is putting a negative in the wrong place and everything goes to heck. So my advice to you is be neat, take your time, write clearly, double check your work as you go, and it will help avoid issues of that sort. Okay, so I'll do one more with you, but the next one I'm going to do, I believe, is what it looks like whenever you have no solution. So I want to show you what that looks like when you're working with a 3-variable system. So since the solution is going to come out a little bit different than the other one, we're not going to probably see all the same steps this time, but I'll still stick to them as much as I can. Okay, so here we go. Step 1, pick 2 equations. Step 2, pick a variable. I'm going to cancel the t this time. Notice how they're already opposites. That will save me some time if I pick the one where they're already opposites. So 5 looks like an S. So since those 2 variables, the t's already have opposite signs, we can just combine them together now and cancel them out, right? So putting the r's together, we get 8. Putting the s's together, we get 1 s. And then the t's cancel, and then the 6 and the 15 make negative 21. So there's my first 2-variable equation. Now I need to create another 2-variable equation. So to do that, I'm going to pick 2 different equations. It doesn't matter which 2 you pick, but what does matter is that once you've picked those 2 equations, you do have to make sure that you cancel the same variable out as last time. So since I canceled out the t, I have to cancel out the t this time. If I don't do that, then whenever I put my 2 equations together after this step, they're not gonna match up well because they'll have different variables in them, and that won't be helpful to me. All right, so in this case, I have to cancel out the t's. I don't have a choice. And the t's are not opposites already, so that kind of makes things a little bit more work for me. So I'm going to have to multiply the top by 1 and the bottom by 2. So let's go ahead and do that, distribute. So the top is not going to change because I'm only multiplying it by 1. The bottom, everything's being multiplied by 2. Ew, negative 50. It's a big number. All right, and we're almost there, but we still don't have what we want because I want to cancel out the t's, right? Problem is that they're not opposite signs, though. We need them to be opposite signs, so we have to do that next step, which we change the signs of all the numbers in one of the equations. I'll go ahead and change all the signs here on the bottom. Doesn't matter which one you do, just so long as you change one of them. So now we have 4r minus 12r is going to be negative 8r. 5s, negative 5s plus 4s is negative 1s. The t's cancel like I needed them to. And then positive 50 combined with negative 15 is 35. Okay, so now I've got my two equations that have the same two variables in them, r and s. And so now I'm going to solve that two variable system. So now I'm on step 8. Okay, well, to solve this two variable system, you'll notice that if you want to pick a variable to cancel, so let's pick the r's here, right? Well, they're already opposites, so let's combine together. Those cancel, but uh-oh, look at that. The s's cancel too, so you end up with 0. And on the right side, we have 4, 14, it looks like. Well, we talked about this back when we solved systems of equations earlier. When you end up with a statement like this, where there's no more variables and it's just a statement about two numbers being equal, well, if that statement is false, like this one, obviously 0 is not equal to 14, that you're going to stop and you're going to say there's no solution. But do be aware, if you guys come across a situation where when you're solving two equations, you end up with a statement that is true, like 0 equals 0, if you get that, that's a true statement, right? That means there's infinitely many solutions, okay? So just keep that sort of stuff in mind. But in this case, we have a no solution because of that. All right? So hopefully that was helpful to you guys. You guys got a couple to work with. We'll see how you guys do and talk to you later.